Hello everyone. So today I'm targeting to cover some questions on what we have learned in the previous video. So binary search and answer related type of questions. So we have learned two different templates. If you have not watched the previous video, I would literally suggest you to go and watch out that video first on which template to use for minimizing the maximum answer and which template to use for maximizing the minimum answer. And made you understand the template also, how it works. Okay, so the question here says these are actually lead code questions only. I'll give you the links in the descriptions. You are given an integer array nums where the ith bag contains nums I balls, and you are also given one integer max operations. You can perform the following operation at most max operation times, means maximum this much times only you can perform these operations. Now, what does this operation consist of? You can take any bag of balls and divide it into the two new bags with a positive number of balls. For example, a bag of 5 balls can become two new bags of 1 and 4 balls, or two new bags of 2 and 3 balls. You got okay? So now your penalty is the maximum number of balls in a bag. Maximum number of balls in a bag. So currently for this maximum number of ball is 8. But let's say if I divide this 8 into two parts, let's say 4 and 4. Now the penalty is reduced to 4, but my operations has reduced to 3. Now I'm left with only 3 operations. I can again degrade 1 4 to 2 2 and another 4 as it is, of course. So my operations has reduced to 2. Now I still have one more operation. So what I can do 2 2 2. This 4 I can again make 2 2. This 4 I can again make 2 2 and then 4 and then 2. Now I'm left with one operation. I still have one operation left. So I can make this 4 also 2. So this all will be 2. Now I'm left with no operations. So 2 is the maximum penalty. Maximum number of balls in a bag is 2, and that I need to minimize. So actually this is minimizing the maximum answer related problem, which is our first template which we have learned. Okay, we have to, so basically we have to minimize our answer. Basically we have to minimize our answer. So first let's go through the template. And I've told you we need to make one function. That function, in that function we will pass the mid as our answer. So here our answer is consisting of penalty. So let's say mid is our penalty. Now what does the penalty means? That every ball is at least broken into two. So let's say if my mid is 4, then at least maximum by maximum I should make 4. 8 wouldn't be possible. I should make 4 out of this 8. So how many operations I would needed? In that way I can count the operations. Okay, so my first function will be something where I'm passing some case, but in my main function, the first thing is we need to decide our L and R. Okay, so what should be your L? What should be your minimum answer? You will divide it to as minimum as possible. So it will be 1. And if you cannot divide, I mean, you didn't have any operations, max operations are 0 for you. Let's say, if you didn't have any operations, then your R will be the already maximum value in the array. Already maximum value in the array, which is 8. So your answer could lie between this two only. Okay, you can divide it and make it all 1 1 1 1 1. Okay, you can't make it 0, of course. Or you make it as maximum value. So you will not divide it only. So of course your penalty will be 8. Okay, so max value. Now you start with the approach while R minus L greater than 1. What do? We'll find one mid. If if the condition is satisfying for mid, so let's say if I take mid as the maximum penalty and I'm counting the total number of operations, and if that operations, so I'll pass this all things, and if that operations are less than or equal to max operations, what I need, that the number of operations should be less than or equal to. So if I consider mid as my maximum penalty, and if I'll find the operations and if it is less than or equal to max operations, then okay, mid could be my answer, or something lesser than mid could be my answer. Because if I take lesser than mid also, then I need to check. But for greater than mid, of course it will satisfy for greater than mid. Okay, of course it will satisfy for greater than mid. We have seen this is the case. So if it has been satisfied for the mid, Of course, it will satisfy for greater than mid. Okay, the operations will be less also. It will be less only in that case. But we need to check it for as left as possible, as minimum answer as possible. So my mid could be the answer or something on the left side of it. So I'll make my R as mid. Otherwise, I'll make L as mid plus 1. So if it is not possible, then if it is not possible at this stage, of course, I need to go and try for the next one only. I hope you got. Okay. And after coming out, we have two operations. So we will first check for the L. We will first check for the L. If it is giving us the results, if it is satisfying, else we will return R. Now the logic main lies in the here. So this is not a new thing for you to make a function like this. Now you know that you have to make mid as your maximum penalty. So let's say here you have to make, as of now, let's consider that 4 is the maximum penalty. So let's say 4 you have to make as the maximum penalty. Then of course 2 is not needed to break. 4 is not needed to break. 8 I need to break. So in how many operations I can make? I can break 8 so that I can make 4 or nothing more than 4. Of course 8 divided by 4. But do I need two operations? No, I would need only one operation. In one operation it will be two fours. Okay, but what if instead of 8 there is 9 and I have to make it to 4? So it should be 4 4 1. Correct? It should be 4 4 1. I need to break it into the 4 or lesser than 4s, not greater than 4. So it should not be 4 and 5. No, this shouldn't be the case. This shouldn't be the case. This is wrong. The only thing you can do is 4 4 1. This is the only correct thing. So how many operations needed over here? 9 by 4, which is 3. Correct? 9 by 4 is 2. Sorry. 9 by 4 is what? 2. So in two operations you can do it. So in first operation you will make in first operation you will make 4 and 5, and then in second operation you will make 4 4 and 1. So in two operations you will make it into 4 4 1. So three parts you have to do, but operations needed is always one lesser. Okay, so when you will find that when modulo is 0, so when something modulo this is 0, you need 8 divided by 4 minus 1, else you will need 9 divided by 4. That means whatever is the number divided by whatever penalty you want. So here we want the penalty as mid. Our operations are max operations, something defined over here. So we'll count the total number of operations needed to make mid as our maximum penalty. Okay, so what we'll do, we'll go for each step. Okay, if if our nums of I is greater than mid, then only we need to break. Okay, then only we need to break. Then what we will do, count plus equal to total number of steps needed is numsci divide by mid. But if numsci modulo mid is 0, that means we need one lesser operation. So we'll decrease the count by 1. So this count is our the total number of operations. So when this will solve will return true when this number of operations needed for the mid as maximum penalty is less than or equal to our total maximum operations given in the question. I hope you got. So this is related to floor and seal kind of questions. There are so many questions like this. I can give you in the description. You can try. Mostly the solve functionality will be same. You need to just think a little bit. A little tweaking will be needed to solve this type of questions. It would be majorly a floor or seal only of the numbers given. Okay. Consider the mid as your answer. Here are the answer is what? You need to return the penalty, maximum, minimum possible penalty. So consider that you have to make mid as your penalty. So mid should be the largest number only after dividing. So then how many operations needed? That number of operations, of course, should be lesser than our maximum operations. Then only it is possible to make mid as your penalty. I hope I'm clear with this. Okay, let's quickly solve it. We can solve this question. Let's quickly solve it. Okay, so we are given this. First, let's make the solve function. So the server mid Fine. What we do, this is the total number of operations. This count is the total number of operations needed considering mid as your penalty. If nums of I is greater than mid, then count plus equal to what? Nums I divided by mid. If at all you not put this greater than condition, then also your count will be 0 in that case, for sure. But better to put it. Now, if nums I modulo mid is 0, you have got this condition by testing it for 2 3 numbers. Okay, so it's better to test for some numbers and then come through the conclusion. Then you will do it 1 minus minus. Okay, return this count should be less than or equal to max operations needed, then only it's true. Okay, now we have L as 1, R as maximum element from nums dot begin, nums dot end. So this max element is the direct STL function. The star will give us the number, otherwise the pointer. And from which array? From nums full start to end array, the maximum element. Okay. While R minus L greater than 1, our mid could be L plus R minus L divided by 2. We'll first check if it's possible for mid. If it's possible for mid, so we need to go it as left as we can. Mid could be the answer or something on left of mid. Else, of course, we need to check on the right of mid only. If this is getting true for L, so we will first check for the L. Now we are left with two numbers as we have discussed, L and R. The answer will be from this two only. So we'll first check for the minimum value because we need to return the minimum answer. If it is getting true, our L is the correct answer, else our R. I hope you got it. Okay, so another question says we are given an array nums and an integer k. We have to split nums into k non-empty subarrays such that the largest sum of any subarray is minimized. We have to split it into k subarrays and split it. So we can either make 7, 2, 5, 10, 8, 7, 2, 5, 10, 8, 7, 2, 5, 10, 8, 7, 2, 5, 10, and 8. These are the four different ways which we can split. We cannot split it like 7, 2, and 8, and 5, and 10. No. We have to split it in subarrays only, not in a random order. And we have to return the minimized largest sum. So from all these four ways, these are the four ways. It could be 7, 2, 7 and 2, 5, 10, 8. And then it could be 7 and 2 and 5, 10, and 8. Or it could be 7, 2, 5 and 10, 8. Or it could be 7, 2, 5, 10 and 8. So these are the four different ways which we can split it. Okay. Now the thing is, like, from this to 7, this is the sum 7, and this is 2 plus 5, 7 plus 10, 17 plus 8, something different, something greater sum. So for all this, the maximum sum will be here. For this case, it will be something like 24, 25. Here for this case will be 15 plus 8, which is again 22. Okay, for this case it will be 18 maximum, and for this case it will be 17 plus 2, 19 plus 5, 24. So the minimum of all this will be 18. So this, which is the third pair, which is the third pair. So we have to return that largest sum which you have minimized. So it's again the same type of question. We need the final answer to be as minimum as possible, but that final answer is the maximum of both of this splitting. Okay. So again, what we will do, we will make this final answer as our mid. Is this final answer possible? And we could make it into k non-empty subarrays. Okay. Now, for making it true, it should not be always making it into k exact equal subarrays. Yeah, I know that the question says we want it in k equal subparts only. But keeping this as the answer, if I'm making 18 as the largest answer, and if I'm dividing it, it should be either k or less than k, or less than k. Then only it could be possible. It should be either k or less than k parts I could make. If I have, if for making it into the 18, if I need more than two parts, then of course it is not possible. But if I need less than two parts to make it 18, okay, let's say to make it 18, I need less than two parts. So let's say there is the one with 18, 7 and 3. So I could make it in this part 18 and 7 and 3. So I could break it into two parts. Okay. So this could be one of the case. But let's say if my case given that we have to break it into three parts only, then this could also be my answer, right? This way I can also break. So making 18 as my answer or mid as your answer, you need to split it into the sub arrays, and you need to count that in how many splittings you can maintain this to be the answer, 18 to be the maximum answer. So that splitters needs to be of course less than or equal to k. Then you can make it greater, then you can split it into more parts. But if it is already greater, you cannot make it. Okay, so this is the way you need to think in making the condition. Mostly it wouldn't be given like max operations, that at most this much operations, there you know. Here you didn't know, you need to make it into exact k parts only. But let's say here our k is 3, but you can make it 18 in two parts only. Okay, you can make 18 in two parts only. So your count will be 2. In this case, our solve function will return true, because you can make it into two parts giving 18 as the sum. Then of course you can make 3 out of those two parts also. I hope you got. Okay, so there will be one solve function. The main function will remain as it is as the above. Okay, so this could be your mid, and you will have one nums array and one key. Now the approach main logic lies over here, that you need to find the number of parts you can make considering this mid as the possible maximum answer. Okay, so let's say your initial sum is 0, and you of course need one subarray. Of course, you will need one subarray. Considering this nums wouldn't be the empty. So consider that now you are starting to make first subarray. So this count is representing number of subarrays needed. Number of subarrays with mid as maximum sum. Okay, so consider that this is your first subarray. Now you will go. What you need to check, if in the existing sum, if I'm adding this current element and if I'm getting it less than or equal to mid. Okay, if I'm getting this sum as less than or equal to mid, so let's say up until now I've got the sum as 15, and now the next element came as 3. 15 plus 3 is less than equal to 18, so 18 is my mid. So then it's okay, I can put that 3 into my original subarray or existing subarray. I can put it into my existing subarray. Okay, so what we will do, we can put it into our existing subarray. So we'll make the sum as nums of I. But what if it is greater than mid? So if your already sum is 80 15, and you got the new element as 4, so 15 plus 4 is 19, which is greater than 18. So now what you need to do, you need to make another subarray. So this is your counting of number of subarrays, and now your sum has become only nums I. So now that subarray has filled. Done. You're done with that subarray, because we have to do the continuous breaks. 7, 2, 5, 10, 8. 7, 2, 5, 10, 8. It's not like 7, 2, and 10, and 5 and 8. No, it's not like this. It's the continuous partitions which you have to make. So there, okay, now you are done with your first subarray. That sum has already become mid or something less than mid. Now if I add this, it will become greater than mid. So I need to make a new subarray. So I've incremented that count. I've incremented the subarray sum, and I have made that sum to be the, now in that subarray there will be only one element, which is this particular uh, nums of I. So done. Okay, and now this count should be less than or equal to k, as we have discussed. So this count should be less than or equal to k. I hope you got it, and the rest will of course be as it is. So if you have got this number of subarrays, this could be your answer. Okay, this could be your answer or something lesser than this. So if you have got 18 as the maximum sum, you need to try for 17. Is 17 possible as the answer? Okay, that you need to check. Now, if it is not possible for 17, then of course it's 18. You cannot go beyond 18. If it is possible for 18 as your answer, of course 19 will be your answer. It could be possible. Let's quickly code it and you will get it clearly. Okay, so this is the Leetcode hard question. Let's first make a Boolean solve. Okay, this will be your mid as the maximum possible answer. Okay, now uh, you need to have two things: sum and count. Count I'm making initially 1 because nums wouldn't be empty. Nums length will be at least 1. It's not 0. Okay, so at least we need first one subarray. So I'm considering this as the first subarray. And now if sum plus if I'm adding this current element, it's less than equal to mid, no issues. I can add it to the current subarray only. So I'm adding it into the sum. Otherwise, I need to make new subarray where the sum will be this thing only. Okay, and you need to return this count as less than equal to k. Now, what will you make your L and R in this case? So what could be your minimum answer? If you split it into, let's say your k is given, your k is given like minimum of 50 comma nums length. So maximum you can make is nums length splittings only you can make. So how many splits? And it's given that non-empty subarrays. Okay, so every subarray has at least one element. So your minimum answer will be minimum element and your maximum answer will be sum. If you could not make any split, this is the whole array without making any split, then this full sum is your maximum answer. Okay, so in this case, your L will be the minimum answer, the minimum element from this full array. Because if you will break it, sorry, maximum element, yeah. If you will break it in single parts like 7, 2, 5, 10, 8, all single parts, that could be the best case scenario if your k is given in such a way. Then 10 is the maximum answer you have got. So the max element will be your L. It shouldn't be less than it because you have to make non-empty subarrays. And your R will be the sum. So we need to make one sum, and your R will be the sum. Okay, of the full array if you are not splitting it. Cool. Now while R minus L greater than 1, int mid is L plus R minus L divided by 2. If it's possible for mid, then of course your R could be mid because this is a similar pattern only. Otherwise, L needs to be mid plus 1. Again, you need to check for both of this case. If solve is possible for L, nums and k will return L, else we will return R. I hope you got my point. Okay, in the next video, we'll see the maximizing related answers. Maximizing related answers. These all we have seen is related to the minimizing ones. Next video, we will see the maximize related answers. I hope you got based on the template how to solve it. Okay, stay tuned, stay safe for the next video. Do like, share, and subscribe with your friends. I'll be sharing a lot of similar kind of questions related to minimizing the maximum answers in the description. So do check the description. There are a lot many questions. Please try to solve it. Mostly the solve function in all of this will be either the floor function or the seal function. So try to get it. Try to initialize. Try to make instinct of what could be your L and R in the binary search. Okay, I'll be giving you in the description.